In today's lecture, we're going to focus on how to compare groups or how to deal with two categorical variables and studying the relationship between them. But before we get into the main part of our lecture, let's take a look at a couple of review questions. So our review questions today are going to focus on hypothesis tests because those are the really core of what we need to be able to do for pretty much the rest of the semester. So the first question we have is, I am giving a research hypothesis. Now, we haven't maybe explicitly talked about what research hypotheses are before, but a research hypothesis is basically what the researchers expect might happen, like if their theory is true or something like that. And so the hypothesis is usually going to correspond to an alternative hypothesis or be basically the same as the alternative hypothesis. So if my research hypothesis is that men are taller than women, what should my null and my alternative hypotheses be? Well, remember, the null hypothesis always has to be very formal, or sorry, not formal, it has to be very precise. And our null hypothesis is usually going to indicate that there's no difference if we're talking about comparing groups. And so in this case, our null hypothesis is going to be that the average height for men is equal to the average height for women. We could also write this as there's no difference, or say this is there's no difference between the height of men and the height of women. But this is one way we might express a null hypothesis. What would our alternative hypothesis be then? Well, like I said, the alternative hypothesis is usually going to sound the same as our research hypothesis. So if we write that out formally, we're going to get something like the average height of men is greater than the average height of women. And notice that this is a one-tailed alternative hypothesis. If we were to write that as a two-tailed alternative hypothesis, then we would say that they're not equal. All right, let's move on to our next review question. So here I have some output from Stata for a t-test, and I'm asking you to tell me what the null hypothesis is. Now, you may not have seen a t-test being conducted with this syntax because the t-test that we looked at in the last lecture, we were comparing two different groups. Here, we're just doing a t-test with one group. We have a sample of items, and we're trying to test whether or not we know something about the price. You can see that price is the variable that's listed right here. So do you have any idea what the null hypothesis might be, how we could look for that? Well, there's a few clues. First of all, this right here, I said usually when we're looking at p-values, we want to look at the one in the middle. This one right here is our main p-value for a two-sided test at least. Right above the p-value, we see a statement of the alternative hypothesis, HA. And here it says what? Mean, or if you'll remember that exclamation point in Stata means not, so mean does not equal 6,000. Well, if the alternative hypothesis is that the mean does not equal 6,000, then what must be the null hypothesis? The null hypothesis has to be that the mean is equal to 6,000. And indeed, that is what the null hypothesis is here. The other place we can see the null hypothesis being written out is right here when we enter the command into Stata. So sometimes the null hypothesis is actually going to be a part of the command that you enter at the beginning. All right, that wasn't exactly review. That was actually extending a bit what we've learned before, but it's a good way to review some of the concepts. So what can we conclude based on our output? Well, again, if we want to reach a conclusion about a hypothesis test, we're always going to look at the p-value. And what is our p-value? It's 0.63 if we look at this p-value in the middle, which is usually the one we default to. What do we compare that to? Well, normally we would compare it to 0.05. We could pick a different alpha level, but if we don't know what the alpha level is, we usually assume it's 0.05. Is p bigger or smaller than 0.05? Of course, it's bigger. When p is bigger than 0.05, what do we conclude? Well, we conclude nothing. We get inconclusive results because we failed to reject the null hypothesis. So we're not going to be able to conclude anything. Maybe we need to go collect some more data before we can reach a conclusion. All right, one last set of review questions. Tell me which of these are which of these alternative hypotheses are one-tailed versus two-tailed hypotheses tests. So all three of these are alternative hypotheses. None of them have an equal sign. We have a not equal sign, of course, in the middle one, but we don't have an equal sign like we would expect with a null hypothesis. So these are all alternative hypotheses. Are they one-tailed or two-tailed? Well, the simplest way to gauge if it's a one-tailed or two-tailed is that the two-tailed is usually going to have a not equal sign. And so we can see that answer one is a two-tailed, or item one is a two-tailed alternative hypothesis. Whereas if we have a greater than or less than sign, we're usually talking about a one-tailed test. And indeed, this one and this one are both one-tailed tests. All right, that's it for our review. In the next video, we'll learn more about how to do an analysis where we look at the relationship between two qualitative or categorical variables.